The James Webb Space Telescope isn't just designed to look at dying stars or stellar nurseries. One of its most hotly anticipated missions is to investigate exoplanets, distant worlds orbiting stars outside our solar system, in search of atmospheres that might support life. This is a game changer. For the first time in history, we now have a tool capable of analyzing the chemical makeup of alien atmospheres. By studying how a planet's atmosphere filters the light of its star, Webb can detect elements like water vapor, methane, carbon dioxide, and even ozone, potential markers of biological processes. Imagine what it would mean to detect an Earth-like planet with a breathable atmosphere. That wouldn't just be a scientific milestone. It would redefine humanity's place in the cosmos. But Webb's power doesn't stop there. It is also revealing the secrets of us young galaxies that formed shortly after the Big Bang. These ancient light sources, invisible to most telescopes, are now within our grasp thanks to Webb's infrared sensitivity and massive mirror. When we observe these early galaxies, we're literally looking back in time, more than 13 billion years. What do they tell us? That the early universe was far more chaotic, structured, and surprising than we expected. Galaxies were forming earlier and faster, with more mass and complexity than any previous model had predicted. This challenges long-held assumptions in cosmology and forces scientists to rethink the timeline of galactic evolution. Now take a moment to picture this. You step outside at night and look up at the sky. You see stars, constellations, maybe a planet or two. But what you're seeing, as vast and beautiful as it seems, is just a fraction of what's out there. Was light pollution, atmospheric distortion, and the limits of human eyesight prevent us from seeing the true majesty of space. Thankfully, tools like the Hubble Space Telescope gave us the first taste of what lies beyond. Orbiting at around 550 kilometers above Earth, Hubble showed us vibrant nebulae, massive star clusters, and the deep field views that became icons of astronomy. It changed our understanding of astrophysics, revolutionized cosmology, and inspired a new generation of stargazers. But now, Webb takes us deeper. Not just in terms of distance, but in clarity, depth, and meaning. Where Hubble left off, Webb begins, able to see the faintest glimmers of the first light in the cosmos. Webb doesn't just show us images, it delivers data-rich windows into the physics of the universe. It enables us to ask bigger questions and actually start answering them. Where did the first galaxies come from? How do they evolve? Why are some galaxies spiral while others are elliptical? Are black holes essential to galaxy formation? What happens to matter at the edges of time and gravity? Every new image, every data set brings us closer to answers. And even more exciting, to questions we haven't even thought of yet. With each revelation, Webb not only brings distant objects into focus, but brings ourselves into sharper clarity. We begin to understand that we are part of a vast, ever-changing, interconnected universe that has been unfolding for billions of years and will continue long after we're gone. That perspective is both humbling and empowering. It challenges us to look beyond borders, beyond conflicts, and beyond the narrow focus of daily life. Because when you're looking across 1.5 billion years of history, everything else seems small. And yet, despite the scale, it is precisely this cosmic perspective that reminds us of how special life is, how rare it might be, and how important it is to cherish our fragile world. Infinity Beyond invites you to join this journey not just as a viewer, but as a fellow explorer. Together, we'll uncover the universe's greatest mysteries and perhaps redefine what it means to be human.